Okay, so today, last week we talked about mensuration one, but we started with circle, which is the part of a circle. We talked about the various parts of a circle and their names. We also talked about the perimeter and the area of a circle, how it is being calculated, and the rest. Yeah, we talked about a lot of things: sector, segment, chord, diameter, and the rest. I gave an assignment, right? So if you are done with the assignment, can I see your answer in the chat box? Give me your answer in the chat box, or you can unmute yourself and talk. But I'll prefer giving me your answer in the chat box. Hello, Daniel, Lisa, Maunya, Michael, Samuel. I'm waiting for your answer. Oh, you didn't do it. Who did the assignment? Actually, who did it?
I did it.
Okay. Okay, Michael also did this. Okay, so can I see your answer? Or can I hear your answer? Whichever way you think is okay. Hello? Wow, okay, yeah, let's continue. Okay, so we ended that with circles, and today we'll be looking at other plane figures.
Sir, does it mean that they are not doing the assignment?
Yes, yeah.
I sent it to you privately. I sent you the answer.
Yeah, you can send the answer privately, or yeah, you can send it privately.
I've already sent it to her. I should send it to everyone.
You can send it to everyone too. I just want to see that you have done it.
Hello, sir.
I've sent it.
Yeah. Yes, boss.
Lisa, he will look at it. One person, Francesca, I think she just joined. So maybe just take her through how she can use the chat and okay, let me just tell you, Francesca, you can hear us. As the class is ongoing, if you want to how do you call it, raise your hand and ask a question, you press the more at the bottom right of your phone. And then you will see chat, claim, host, raise, and you use the raise and you raise your hand, your teacher will see and call you out. If he asks a question and he asks you to send it through the chat to you, use the chat. When you press the more, the chat is the first thing you will see on top. You press the chat, you'll be able to chat the teacher privately. His name is Prince. And you can also send it to everyone, he will still see it. And so I think, sir, you can carry on.
Okay. Nice one there. Oh, okay. Nice one there, Michael. Nice one there, Lisa. Nice one, nice one. Mawinya, don't worry. The next assignment, you can get it and do it, okay? Okay, so nice answers there, nice answers there. Let's continue with today's lesson. Today we'll be learning about perimeter and area of other plane figures other than the circle, okay? Other plane figures other than the circle. We have plane figures such as rectangle, parallelogram, square, and the rest, okay? So we'll be learning about other plane figures other than the circle. The perimeter of a plane, as last week we learned, is the length of its boundary. The perimeter of a plane is the length of its boundary. So, for example, you have this rectangle. For example, you have this rectangle. The perimeter of this rectangle is the length of its boundary. So the length of this shape's boundary is the perimeter. So this is a length, this is another length, this is another length, this is another length. That's the perimeter of this shape here. And as we learned last week in circles, you could see that the perimeter of the circle is the circumference. That's the length of this circle. Is that okay? So it's the same idea here. That's the perimeter. Now, the area of a plane shape is the amount of surface enclosed between its boundaries. The amount of surface enclosed between its boundary. So you could see that inside this plane shape, there is an area here. Is that okay? Let's take a football field where the linesman will be standing. Is that okay? This will be it. This will be it. Now, inside it is where the football field is. So that's the area of that football field. And the perimeter is the length of it. So these lines, okay? Now, the length, that is the perimeter, is measured in length units. That is meter, centimeter, etc. And the area is measured in squared units. That is the length unit squared. That's meter squared, centimeter squared, etc., etc. Now, we will take the shapes one by one, and as I've said, you have already learned this one in JHS, but maybe you are not so conversant with it. So we'll go over again, solve more examples, then you get the concept. Okay. So for a rectangle is a four-sided figure. A rectangle is a four-sided figure. So any four-sided figure you see is a rectangle. But with this kind of rectangle, it has the opposite sides being equal. So a rectangle is a four-sided figure with the opposite side being equal. Sorry, give me a minute. Now. Okay, so a rectangle is a four-sided figure with the opposite side being equal. So as you can see in this plane shape here, we have a long length here, we have another long one here, then we have a shorter one, which we normally call the width. Okay, so this is a rectangle. It has this four sides with two sides being equal. We call them parallel. Okay, so this line is parallel to this line, and this line too is also parallel to this line. Therefore, the length of this line is the same as the length of this line, and the length of the width here is the same as the length of the width here. Therefore, that's a rectangle for you. Now, the perimeter of a rectangle, to find the perimeter, you sum up all the sides. So this side plus this plus this plus this will give you the perimeter of what? The rectangle. Is that okay? To give you the perimeter of the rectangle. As we did in circles last time, to find the perimeter of a circle, you have to walk around the circle. Is that okay? This one, so if you want to find the perimeter of maybe a football field, you have to walk around the football field. Is that okay? To find the length, maybe using a tape measure or something. Is that okay? So that's the perimeter. You are finding the length of the size of what? The shape there. Exactly. So you sum up all sides. And since two sides are equal, this place being the length, it is equal to this place. Therefore, we call this place to the length. And this place being the width is equal to this side, and we call this side to the width. Exactly. So to find the perimeter of this rectangle, you sum up all the sides, which is one length plus another length. That's two lengths. We represent it with 2L. Then one width plus another width, which is two width. We represent it with what? 2W. So that's the perimeter of what? A rectangle. To find the area of a rectangle, we want to find the area in here. Is that okay? We are finding the area in here. Therefore, you multiply the length by the width. You multiply the length by the width, and that will give you what? The area of the rectangle. Therefore, perimeter of the rectangle is 2L plus 2W, and area is L times W. You have to get this in your head. Perimeter of a rectangle, 2L plus 2W. Area is length times W. Okay, so let's take an example.
Sir.
Yes.
Hello. What's no
Yeah, I'm listening. Samuel.
Now it's talking. What's talking, sir?
Hello, Samuel. Good. Okay, so let's take it in a shape first, then we can continue with new share, whiteboard, share, draw. Okay, so text. Okay, so this is it. Find the perimeter and the area of this rectangle here. You have 2 minutes. The area and perimeter of this rectangle, you have 2 minutes. Samuel, are you done? Samuel, are you done? Okay, Nana, I think I've unmuted you, so are you done?
Yes, please.
Okay, so what's the answer?
The perimeter is 18 centimeters.
Okay.
And the area is 27 centimeters square.
Okay. Nice answers there. Any other person? If you are done, you can put it in the chat box. I'll be reading from there. Nice one there, Nana. Hello. I thought you guys use calculator, or you don't use calculator again. Hmm. Nice one there, Michael. Nice one there. Nice one there, Michael. Daniel, nice one there. Daniel, nice one there. Nana is back. Nice one there. Nice one there. Nice one there. Drosel, nice one there. Okay, Lisa is off. That's why. Of a square is 4L. I hope that's clear. So let's take another example on this one. After that, I'll give you a more complicated example to solve. Okay. Okay, so we have this square with size 4 centimeters. Find the perimeter in the area. This shouldn't take you more than a minute. When you find this in an exam question, it's a bonus question altogether, and it shouldn't take you more than a minute.
Sir.
Yes.
Sir.
Yes, please
Please,
speak.
the perimeter is 16 centimeters.
Beautiful.
And the area is 16 centimeters square.
Nice one there. Nice one there. Okay. Francesca. Hey. Today the names are okay. I like it. Nice one there. Nice one there, Francesca. Bridgetta, welcome. Nice one there, Nana. Well done. I'm waiting for the rest too. I didn't say it was correct or it was wrong. I just said nice one there. So please fill in your answers. Nice one there, Lisa. Nice one there, Daniel. Daniela Samoa. We have 2 Daniels. Mawunya, nice one there. Drosel, nice one there. Johnson, I'm not seeing you, Johnson. Michael Fosu, nice one there. Bridgetta, let me feel your handwriting, okay? Let me hear your handwriting in the chat box. As Obinim will say, let me see your shouting. Okay, let's continue. The rest, please, the next question will be for you. Those who didn't comment, the next question will be for you. Nice one there, Johnson. Well done. Okay, so let's solve it now. So we have our perimeter to be equal to 4L, that's 4 by L. And we have the length to be 4 centimeters. So 4 by 4 give us what? 16. Okay, 2 more answers. Okay, nice one, Johnson. Nice one, Mawunya. Another one. You have done well. You have all done well. Then our area is L squared. And our L is 4. So 4 squared will give us what? 16 centimeters squared. This one is 16 centimeters. Okay. Nice one there, all of you. You have all done well. Let's continue. Okay. So before we move on to triangle, Okay, so my drawing will not be that perfect. But for the benefit of doubt, this side is a square. My drawing will not be that perfect. So maybe some people will take it to be a rectangle. Please, it's not a rectangle. I'm telling you that it's a square. Okay, so this is it. So you have to find the area of the figure below. Find the area of the figure that you are seeing. You have to find the area of the figure. I'm giving you like 5 minutes. Find the area of the figure. Sorry, take all the two to be rectangles, okay? Don't take this to be a square. Take all the two to be rectangles and find the area. Oh my God. Nice one there, Johnson. Nice one there, Francesca. Hey, the name, can I mention it? Francesca. Okay, Francesca. Nice one there, Lisa. Daniel, nice one there. Nice one there, Daniel. Rosel, nice one. Nana, nice one. Nice one there, Nana. Nice one there, Rosel. Brigitta, yeah, I've seen your handwriting now. Nice one there, Brigitta. I've not heard from Daniel Daki. I've not heard from you. Michael, I've not heard from you on this question. Samuel, I've not heard from you from this question. Okay, so your 5 minutes is up. Let's solve it. Okay, so we have two rectangles. Okay, we have rectangle A and rectangle B, as I've said. Oh, okay. Okay. Maybe it's having some small technical challenges. Okay, so we have two shapes. That's two rectangles here, rectangle A, rectangle B. Now, as you can see, rectangles A's width is 2 centimeters. It's clear here. And the length is 7 centimeters. It is also clear here. Exactly. So rectangle A, for rectangle A, you'll be getting what? The area to be length times breadth, which is equal to the length is 7 and the breadth is 2. And that will give us what? 14 centimeters squared. Then we have rectangle B, which is also length times breadth. In this instance, it is not that clear. So let's see how we can find it, okay? So we have the full length here to be 7 centimeters, but this side to be 2 centimeters. Is that okay? This side to be 2 centimeters. Therefore, the rest of the length here will be what? 5 centimeters and not 7 centimeters. So we'll be having 5 by. Then we have another one, which is the full length here to be 7 centimeters. From here to here is 7 centimeters. But from here to here is 4 centimeters. Therefore, we subtract 7 from 4 to get this broken line here. That is what? 3 centimeters. Therefore, 5 by 3. And that will give us 15 centimeters squared. Now, after that, all you need to do is to add the area of rectangle A and the area of rectangle B. So our normal addition, which is 14 centimeters squared plus 15 centimeters squared, and that will be equal to 29 centimeters squared. I hope you get it. Okay, so this is it. Those who had this correct, well done. Those who had this wrong, I hope you have found that you have found your mistake now, and you can do better next time. More room for improvement. Don't be discouraged there. You get it correct next time. Okay. So that's it. So let's move on to triangles. Now, a triangle is a three-sided plane figure. A triangle is a three-sided plane figure. So we have side 1, side 2, and side 3. Now, any of the sides can be the base. So this side can be the base, this side can be the base, this side can be the base. The height is this line in here. Is that okay? This is the height. So from the apex to the base is the height. Therefore, you can have another height like this from this side, which when you turn the rectangle, it will be the apex to the base. This is another height. If you have this one to be the apex, when you turn it, you push it to the base. This is another height. And it's like we are doing construction. Is that okay? So the height is the line from the apex to the base. And any of the sides can be what? The base. Therefore, drawing a line from the apex to the base will give you the height. Drawing another line from the apex, it will give you the height. Therefore, the height is not a constant, this one, but it can move from here to here or here to here. But any of the sides can be called what? The base. Is that okay? Now, the perimeter of a triangle, which is the sum of all the sides. So we have side 1, side 2, side 3. You sum it up and you get what? The perimeter. Is that okay? So you side all the bases together, then you get what? A perimeter. You sum all the bases together, then you get the perimeter. Now, the area of a triangle is half of the base. Half of the base times height. As you can see, the height divides the triangle into two. Is that okay? The height divides the triangle into two. Therefore, it gives us this a base of half base here, another half base here. Is that okay? So to get the area of a triangle, it is the half of the base times the height. That will give you the area of a triangle. Is that okay? So an example, find the area of a triangle. Find the area of a triangle with 4 centimeters base and 5 centimeters height. This one shouldn't take you like 1 minute. It's a very, 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 very simple question. Nice one, Johnson. Nice one, Francesca. Hey, the name Francesca. Nice one, Lisa. Nice one, Anna. Yes, the rest, I'm waiting for you. Brigitta, Daniel, Drozel, Mawunya, Michael, Petra. Petra, welcome, eh? Petra and Samuel. Hey, Samuel can hear us. Okay, so let's solve it very, very, very fast. So we are using the formula half base times height. Is that okay? So half of the base, which is what? 4 centimeters, times the height, which is what? 5 centimeters. Half of 4 is what? 2. Oh, okay, Michael has given the answer. Nice one. It skipped me. Nice one, Michael. Okay, so half of the base, that is 4, will give us 2 times the height, which is 5 centimeters, and that will give us what? 10 centimeters squared. Exactly, 10 centimeters squared. Now, to find the perimeter of a rectangle, you have to know the kind of rectangle you are dealing with. Because the perimeter of the rectangle is the sum of all the bases. So you have to know the kind of triangle. I said rectangle, triangle, sorry. You have to know the kind of triangle you are dealing with, okay? So the types of triangles, we have one, that's the isosceles triangle. It is a triangle with two sides being the same. This one we learned is JHS. I hope you remember. So you will not waste my time there. An isosceles triangle is a triangle with two of the sides being the same. That's two of the bases being the same. So maybe this base is 4 centimeters. This base will also be 4 centimeters. Whereas this base will be either 5 centimeters, 6 centimeters, or anything that is not 4 centimeters. Is that okay? So an isosceles triangle is a triangle with two sides being the same. Now the next one is an equilateral triangle, which is a triangle with all sides being equal. Equilateral. So you have all the sides being equal. You have this side, and this side, all being what? Equal. That's an equilateral triangle. Therefore, to find the perimeter of an equilateral triangle, you have to just know the side of the length of just one side. Then you multiply it by 3. Exactly. Then you multiply by 3. But for isosceles triangle, to find the perimeter, you find the length of two sides. So you find the length of the one side that is equal. Then you can multiply it by 2 and add it to the one that is not equal. Exactly. But for isosceles, you just add all the 3 sides together and you could see that they are all the same. Now, the last one is a right angle triangle, which is a triangle which with one angle as a right angle. Exactly. As you can see, this triangle, you can add another one to it here. And we can get a full triangle. Exactly. But it is only this side that it is showing. So it is having what? A right angle. So that's a right angle triangle. It's a triangle with one angle as a right angle. Exactly. And right angle is 90 degrees. Right angle is 90 degrees. Okay. So we use this one to also talk about, let's talk about the Pythagoras Theorem. Okay, so let's talk about the Pythagoras Theorem, which says that this side and this side to this side squared. Is that okay? This side, let me label it, then that one will be better. Text, we have, let's name this side C. Let's name this side A. And let's name this side B. Is that okay? Therefore, the sum of the squares of these two sides will be equal to the square of this side. That's the sum of the square of AC and AB will be equal to the square of what? BC. Is that okay? So, for example, and as we did, we named this side A, name this side B, and name this side C. Okay. So you have this right angle triangle. You are supposed to use the Pythagoras theorem to find maybe a length of another one side. Okay, so let's say that you have the length of this side to be 10 centimeters. Okay, so you have the length of this side to be 10 centimeters, and you have the length of this side to be 5 centimeters. Now, the Pythagoras theory says that in finding the perimeter, you can use it, but the Pythagoras theory is normally used to find a side of a triangle, okay, of a right angle triangle. That's a side. So maybe you don't know the side and you want to find it, but the perimeter is just the addition of this sides. So this place plus this place plus this place, that's it. Exactly, that's the perimeter. You just add them, but you want to find a side of the triangle, of the right angle triangle. Therefore, what we are talking about is that, for example, this one I normally use it when I'm walking. Okay, when I'm walking in town, I normally use this kind of theory. I imagine where I'm going, then I check the possible routes that I can take. Now, walking from A, I'm from C and I want to get to B. Exactly. And I have the opportunity to walk from C to A, then from A to B, or from C to B straight away. Which one will you take? I normally take this one because, sorry. Exactly. So I normally take this one because that one is faster. For example, what normally you'll be walking and you'll be having pavements. Now you could see that walking in the pavement takes much longer than walking through the pavement. Exactly. So for example, you are walking and there is this pavement. Exactly. You have to walk through the pavement to get to this side. I want to get here. And I have to walk through the pavement to get to this side. But I could have walked from here to here straight away. But instead, I have to walk from here to here. I have to walk from here to here, then from here to here. Instead, I could have walked through the pavement to here. So you could see that sometimes walking in the pavement is some kind of headache, but what can you do? You have to walk through it to show courtesy and as a gentleman or as a lady. That okay. So that's how the Pythagoras theorem is normally used, but we use it to find a side of a right angle triangle. Okay, so you have this, and what we are saying is that BC squared, that's the length of BC squared, is that okay? It's equal to the length of AB squared plus AC squared. Okay, that's a Pythagoras theorem. So to find the length of CB, so CB squared from here to here, is that okay? That's BC squared in mathematics. It's equal to CA, which we can also term as AC squared plus AB squared. So working from here to here, that's is equal to the same as working from here to here. That's a Pythagoras theorem. So for example, we want to use this one to find the side AC. Is that okay? We have BC squared to be 10 centimeters, but we will be squaring it. So 10 centimeters squared to be equal to AB squared, which is 5 centimeters squared, plus we don't know AC squared. Is that okay? We don't know AC squared. I hope that's okay. For this one, you normally don't have to multiply them by itself because you'll still be finding the square root of this thing. Is that okay? So let's move on and make AC squared the subject. So making AC squared the subject, you'll be getting 10 squared minus 5 squared is equal to AC squared. Is that okay? So you have 10 squared minus 5 squared is equal to AC squared. Let's just find it. So 10 squared is 100. Then minus 5 squared is 25. And that will be equal to AC squared. Now 100 minus 25 will give us 75 is equal to AC squared. Now finding the square root of AC, because we want to remove the square and get the length of AC alone. Therefore, you find the square root of what? Both sides. So finding the square root of AC and the square root of 75, you'll be getting AC to be equal to, you can punch your calculator, it's allowed. Is that okay? So you're getting AC is equal to 8.66. 8.66. 8.66. So that's how we use the Pythagoras theorem. Is that okay? That's how we use the Pythagoras theorem. So when we are given when you are given something like this, and you are told that the base is 10 centimeters. Okay, let's take it to be an equilateral triangle, which all the sides are equal. Okay, and you are told to find the area. Now you know sides. Is that okay? Now we will have to isolate the right angled triangle from this thing. So this is a right angle triangle. Since it is an equilateral triangle, any line moving from the apex to the bottom will divide that triangle into two equal parts, therefore giving us 5 centimeters at each end. Therefore, the length of the base here will be what? 5 centimeters here. The length of this base will give us what? 5 centimeters. Is that okay? Then the length of this side, since it's an equilateral triangle, we have all the sides being equal. And as you can see, from here to here is equal to from here to here. Therefore, we'll be getting 10 centimeters for this side. The height didn't divide this diagonal line, it only divided the base. Therefore, having 5 centimeters and 10 centimeters is the same method we are going to use to do what? To find the height. So that you can multiply half base times height. And it is what? We got what? 8.66, right? So we had the height to be equal to what? 8.66. So that's our height. Therefore, now we can find the area of this triangle. This big triangle. We can find the area of this triangle to be what? Half times the base times the height. And the area will be equal to half of the base, which is what? Now we are talking about the whole triangle and not the right angle triangle. We use the right angle triangle to find the height. So the base is what? 10 centimeters. By the height, which we have found to be what? 8.66 centimeters. Half of 10 will give us what? 5. And 5 by 8.66. And that will give us what? 43.30 centimeters squared. Exactly. That's how we normally use the Pythagoras theorem. I hope everything is cool. Any question? Any question? Any question? Any question? Okay, so if there is no question, I will give out an assignment again today too. And this one, I will expect everyone to do it. Exactly. I will expect everyone to do it. Okay, so let's combine them and give out this assignment. Let's use this one first. Together. Together. Okay, so you are finding the area of this side, the shaded region. You are finding the area. First, you find the area of the full rectangle. The question is A. You let me write it. A. Find the area and perimeter of the rectangle. And B. Find the area of the shaded region. Okay. So I hope all of you have it down. If there is no question, no contribution, no suggestion, we'll be ending the class here. If God willing, next week we'll be meeting. Okay. We take it from there, then we look at other plans.